Hello, everybody. This is the video for practice test number 3. Okay, so this will get you prepared for your test number 3. And the first thing you should do is to go into that module for test 3 and print out practice test 3. Okay, so there's a 21 question document called practice test number 3 for Math 100. And you should probably attempt to do those problems first. Now, there is a written solution key already in the module. And so you don't have to watch this entire video, but if you have a particularly a certain difficulty or a particular challenge with a certain question or a certain group of questions, then you can go to the portion of this video that covers that, that problem or those problems, and you can look carefully and see if you can understand it. All right, so test number 3 covers, as you know, chapters 6, 7, and 8. And so chapter 6 was on linear versus exponential growth and logarithm. And chapter 7 was about math and fine arts. And chapter 8 is about math and politics. This test will cover lessons number 15 through 20. All right, so let's get started. I will cover all of the questions on practice test number 3. Okay, so the first question, the number of cable TV subscribers is increasing by, and here's a key, 5,000 a year. Okay, is this a percentage or a number? Clearly, it's a number. Okay, it's not a rate, it's not doubling, it's just a fixed number. Is this linear or exponential? And so the answer is it is linear. Okay, and let me just go ahead and type something in here. I will see if yes. Okay, so I will try to make it a little bigger and write any growth by a fixed number is linear. Growth by a fixed percentage or rate, of course that's the same thing, is exponential. Okay, so instead of 5,000, if it says 10% a year or something, that would be exponential. All right, let's go to the second one. The population of a country is doubling. Okay, so what is doubling? Is this a fixed number? Well, you know, if a number doubles, you know, like from 1 to 2 and then 2 to 4, 4 to 8, it's clearly not a fixed number, right? So if doubling basically means 100% growth, and 100% is, of course, percentage. And so it is exponential, right? And so you should know the difference between linear and exponential. And I'll have questions, maybe a question or two, very similar to this type of question here. Okay, so know the difference between linear and exponential growth. By the way, it says this is the same idea as the frequency of sound doubling, you know, the frequency of sound doubling every octave in music. That is the doubling kind of growth, which is exponential. Number 3, suppose that a nonprofit organization is doubling its membership every year, and there are 6,400 members this year. This is more specific. When were there only 200 members? Okay, so there are a couple of ways to do this, and maybe the most intuitive way is to write this. Okay, so this is right now, right? And you'll see similar writing on the left margin of the answer key. And then you can start asking your question like, right, so it's doubling every year. So what is it? Like a year ago, you can write this as -1. That's a year ago. There were 3,200 people, right? Why 3,200? Because it's half of this year's membership. 2 years ago, that's half of that at 1,600. 3 years ago, there must have been 800. All I'm doing is just cutting the membership numbers into half. And then 4 years ago, there were 400 people. And of course, 5 years ago, you can see there were 200, and that is the question, 200 members. So the answer is 5 years ago, right? When were there 5 years ago? And then in how many more years would the membership exceed 1 million? That is optimistic, but if this growth continues, right? So then you can keep adding or increasing this, doubling it, 12,800 a year from now, and so on, right? So you could do this, okay? And it's going to take you a while to get up to 1,000 because right now it's 12,800. All right. And then, of course, if you double this, you could say it's going to be 25,600 and keep going. Now, that's one way to do this. Now, some of you are having a hard time finishing a test like this in time, and that's because maybe you are not able to apply more sophisticated methods, right? 1 million seems to be a long way. In fact, it doesn't really take you like years and years, okay? But you may want to just think of an equation. What is the equation that would express this thing here? So 6,400 is the current number, right? And it's doubling, so multiplying by 2, this will give you the membership or the number of members a year from now. And then 2 years from now will be twice that, so you multiply by 2, right? And so basically, the number of people, the number of members in years from now is going to be expressed this year. Remember, this is the initial number or initial quantity or initial condition, 6,400 to the times 2 to the 0th power, current will be 6,400. If n is 1, it'll give you this number. If n is 2, it's going to give you 25,600 and so forth, okay? And you want this to be over a million, right? You want this to be over a million. Okay, now you can just put equal sign and so on. But then, so this you can try, right? So for instance, you can say, well, how about this times 2 to the 10th power, okay? And this is just a guess, okay? But you could try to do something like that instead of going up and up and up this way, 3, 4, 5, and 6, and so on. All right, so if you take 2 to the 10th, remember, this is the first part you have to do. 2 to the 10th times 6,400, you get 6.5 million, all right? You need to be able to read this on your calculator once you do your calculation. Of course, that's too many. All you need is 1 million. So you can divide this by 2, and that's going to give you the result when the exponent is 9, and that's 3.2 million, still too big. You divide this number by 2, and you get the membership as of 8 years from today, and that's 1.6 million. Now, when you get to this number, you know that if you have this, if you take if you divide this by 2, okay, that would be the 7th year membership number. That would be like less than 1 million, because right now you have 1.6 million. Half of that will be about 0.8 million. That's not quite 1 million. So you know the answer has to be this one. Okay, so that's a way to figure this out. The answer is 8 years. All right, so you could have just sort of applied this formula, you know, and this is the power of that explicit formula, not the recursive formula, but the direct formula. And so if you can figure out the direct formula, you can just plug in some likely number like 10 and then make a little adjustment. Otherwise, you can, you know, continue to double these numbers. Okay, so this would be a 3rd year. After 3 years, you will have 51,200. And after 4th year, you have 102,400. After 5th year, you have 204,800. After 6th year, you have 409,600. After 7th year, you have 819,200. And of course, the 8th year, since you have 800,000, 8th year, it'll exceed 1 million, which is the same answers here, okay? But this will take you longer than using this direct number and plugging in a likely solution. All right, okay, let's go to number 4. The population of a small fishing village is growing linearly, this time it's linearly, with an initial population of 800. Okay, after 1 year, the population was 1,000. Okay, so you can tell linear means that there's a constant difference. Okay, so let's see what the constant difference is. After 1 year, the population increased by 200. What will the population be after 5 more years, right? So how do you calculate this? Here are 2 ways to answer that question. Okay, number 1, I have already calculated that the difference is 200, right? So if you want to find the direct formula, remember P sub n is what? you say it's it's the initial value, which is 800, plus 200 times n. Okay, where n is the number of years since now or after right now. Okay, so after 1 year, if you plug in 1 here, you get 1,000. After 2 years, of course, you plug in 2 here and you get 1,200 and so on. All right, and so with this, just all you have to do is to find p sub 6 because it's 5 more years after 1 year, which is 6 years. And so this will be 800 plus 200 times 6. You do this part first, okay? And so you get 2,000. That's 1,200 plus 800, and the answer is 2,000. Okay, so that is the best way to approach this problem here. Of course, if you can't figure this out, if you can't figure the direct formula, okay, you can also do this manually, right? So you can make a little chart and you say P1 is 1,000, P2 is, of course, all you have to do is to add 200 each time, right? And so after 4 years, it's 1,600. After 5 years, it's 1,800. After 6 years, this one doesn't really take a lot of time until you get the correct answer. Of course, there would have been a problem if it says find the population 30 years from now or 100 years from now. Then you do not want to do this manually like this. You probably want to do it this way, using a direct formula that you will have to write down. All right, number 5. The number of licensed truck drivers in the country in 2010 was 4,000 in a country. We are not told what country. And then it's growing by 3% each year. Okay, so this is an exponential growth. Right? Find the explicit formula equation for Pn. Remember, P sub n is always written in the same way. It is the population now, or at a given time at the beginning of this sequence, and then you multiply by, in this case, exponential growth by 3% each year. Remember, it's very much like 3% every year, compounding annually. So you put 1 plus that APR. So 1 plus 0.03, because that is 3%. And then you raise it to the nth power, because that is what happens with exponential growth. Remember, after 1 year, it's 4,000 times 1.03. That's 103% of 4,000. Then the following year, you have to multiply that number P1 by 1.03 again, because it's going to grow to be 103% of P1, right? So it is a continuously, it's increasing in an exponential way. And so n becomes the exponent of this formula. So this is the answer to that question. Pn is 4,000 times 1.03 to the nth power. Okay, part B says then, find the number of licensed truck drivers in the country in 2020. Now, 2020 is what? Starting in 2010, 2020 is when n is equal to 10, because it's 10 years after 2010. Use your calculator, of course, right? So the answer is pretty simple. You're supposed to find P sub 10, which is 4,000 times 1.03 to the 10th power. And remember, you do this part first, okay? And so multiplication. So all you have to do is just do this calculation and you will get your answer. This part will be 1.3439 or something. And so the answer to this question is 5,375.66. Well, you can have 0.66 of a driver. So you would say in this case, because 6 is bigger than 4, you round this up to 5,376 truck drivers approximately. If you're anywhere close to this, if you just truncate this and say 5,375 drivers, I would probably accept it. I'm not going to penalize you for rounding. All right, number 6. What is the log of, what is this number? This comma suggests 1,000. This is million, so it's a log of 1 million, okay? So what is that? Okay, it's basically, again, saying 10 to what number is 1 million? Okay, and when you have numbers with a bunch of zeros following 1, the number of zeros is actually that exponent, right? So it's 10 to the 6 because you have 6 zeros, 1, 2, 3, 4, 5, 6, right? So the answer is that the log of 1,000,000 is the number of the exponent to which you raise 10 in order to get 1,000,000. And so the answer is 6. Okay. And the reason is because 10 to the 6 is 1,000,000. That is the reason. Okay. In other words, when you ask for this common logarithm, the question is 10 to what number is this number in the parentheses, or the number that follows the log symbol. And the answer is, well, because 10 to the 6th is 1,000,000, then log of 1,000,000 would be 6. Okay, remember, the log is, the value of the log is the exponent. The value of the logarithm is the exponent to the base number 10. All right, so hopefully, this is basically what you had in chapter 6, and hopefully you have mastered chapter 6. Let's go to the next part, or the next portion, or the part of the video to start number 7.